This is the last formal video lesson for our trigonometry unit. So this last note we will be talking about the cosine law in acute triangles. So just a reminder that acute triangle just means that all of the angles are under 90 degrees. So it's not a right angle triangle where there is a right angle, and it's not an obtuse triangle where we have an angle that is larger than that 90 degrees. So it says, can we use primary trig ratios? So primary trig ratios is just SOHCAHTOA, right? Sine, cosine, tan. Or the sine law to solve either of these triangles. So remember, the sine law is what we learned in that last note, which stated that the ratios of the side and the angle measurement are all equal. So let's take a look at this first triangle here. So we can see it's the triangle ABC. So we have side lengths 4, 5, and 6. So all we're given is those 3 side lengths. So right away, we see that there's no right angle here in this triangle. So we know we can't use our trig ratios, right? Because our trig ratios can only be used on those right triangles. Okay, so now let's think about the sine law. So remember, in order to use the sine law, we need one full ratio. As we can see here, all we have is those 3 side lengths. So we don't have a full ratio. So we can't use either the trig ratios or the sine law to solve this triangle, right? So just to make note of that, so we need a full ratio or a right angle. Okay, and that's what we would need if we were to use, again, those primary trig ratios or that sine law. Okay, so that triangle there, if I asked you to solve it on a test, you would not know what to do at this point, right? You wouldn't be able to use the information that you have to actually give me an answer there. So let's look at this next triangle, XYZ. So we can see here we're given 2 side lengths and an angle in the middle of them. So again, thinking about those trig ratios, I don't see a right angle, so right away we aren't going to be able to use those trig ratios. And in order to use the sine law, yes, we have an angle and a side here, but we don't have a complete ratio. So in order to use our sine law, remember, you need the corresponding side length to be there. So we would need this side length here to create that full ratio. Okay, so what I wrote on the left-hand side here applies to both of these situations. Okay, so this situation, we have side, side, side. In this situation here, we have side, angle, side. Okay, in neither of those situations are we able to use the trig ratios or the sine law. All right, so just as a quick summary here. So again, the primary trig ratios, which is SOHCAHTOA, okay, are only used to solve right triangles. Okay, the sine law can be used to solve triangles if we know two angles and any side or one angle and 2 sides. Okay, but again, what's most important here is that one of those sides needs to be opposite the angle given. One of the sides okay? So the key there is just it needs to be a full ratio. Those are just stating the different ways that you can get that full ratio, okay? All right, so obviously, if you're given one of those triangles that we kind of investigated at the top, you are going to have to do something with them, and obviously you are going to learn what to do with them in this lesson. Okay, so what we would use is the cosine law. All right, so I am going to write out the cosine law for you. Obviously, you can use this for your final assignment. You are going to want to obviously have them in front of you because honestly, this law is definitely a little bit confusing. So the law states that a squared, so remember a, when it's lowercase letters, they're always side lengths. It's equal to b squared plus c squared minus 2bc times cos a. Okay, so notice the pattern here. So when we're solving for side length a, we can see that we're adding b and c. B and c are the only ones, right, on the right-hand side of the equation. And the angle you're using is the angle of the side you're trying to find, the corresponding angle. Okay, so similarly, if we're looking for b squared, we're going to add the other two sides together, the squares of the other two sides, and then subtract 2 times those sides multiplied by cos and the angle of the side you're trying to find. Same thing with c. Cos c. Okay, so try to notice that pattern. Again, I do not expect you to remember this. If we end up back in class for the final or anything like that, I would absolutely be giving you this formula. You do not need to memorize it. Okay, so that is the formula that we are going to use to find side lengths. Okay, so to find side lengths, we're going to focus on those formulas there. Okay, we can actually modify this formula to help us find angles as well. Okay, so all this second box is showing are basically those formulas in that top box rearranged so that they are isolating the angle. Okay, so again, I'm going to write those out for you. Again, kind of confusing. So if we're looking for angle A, again, you have to remember that a capital letter means an angle. We are going to take the inverse cos of a squared minus b squared minus c squared, all divided by -2 times b times c. Okay, so what you should be noticing here is that we're never dividing by the angle we're trying to find, right? So we're trying to find angle A, so we're dividing by B and C. We never want A on the bottom. Okay, so same thing with B. We're going to end up taking the inverse cos. Okay, because we're solving for angle B, we need side length B to be first here. So B squared minus A squared minus C squared. And that is going to be important. You are going to have to make sure that you are directly substituting here for A, B, and C in the right spot. And again, we're finding B, so we don't want B on the bottom, so we're going to divide by AC. Okay, lastly, for C, again, we're taking that inverse cos. All that's changing, guys, in these equations is the order of the side lengths and what you're dividing for, or dividing by, rather. Okay, so we're finding C, so that means we need side length C to be first in our equation. Notice if A is not out front, it's always second. And that's all going to be divided by -2. We're finding C, so we have A, B on the bottom. Okay, so again, these are just equations, right? Yes, they look a little bit confusing, but they are simply just equations. So as long as you know how to use substitution, you are all good. And obviously, we are going to use these formulas to find angles. And again, just have those in front of you. Use that to your advantage. All right, so now that we have the formula, we have to figure out when can we actually use this cosine law. So the cosine law can be used to solve triangles when given information includes. So when we are given all three side measures or side lengths. Okay, if we're given all three side lengths, we can use this cosine law. Okay? Or we can use it if we are given two side lengths and the angle between them. And I'll draw you a little picture of that. Okay, so actually I don't have to draw you a picture because if we look back at the top of our note, this first triangle, ABC, is situation 1 from below, right? Where we have all three side lengths. This triangle XYZ, we have those two side lengths and the angle between them. So that's situation 2 that we just talked about. Okay, so we can solve both of these triangles above using the cosine law because the first one, we know all three of those side lengths. The second one, we know two sides and the angle between them. And just to kind of help you remember that, like I wrote above, we would have side, angle in the middle, and the other side of that angle. Okay, so let's jump into some examples here now that we have completed the note part of it. So we have 3 examples, kind of standard. Okay, so it says find the measure of the unknown side to the nearest tenth. Again, nearest tenth, guys, just means 1 decimal place. And maybe you want to just remind yourself of that. 1 decimal. Okay, so we can see here we have a side, okay, 8 inches. We have an angle between, and then we have another side. So we know right away we are good to go with using our cosine law. Okay, so the first thing we're going to do is we're going to write out that cosine law with the correct variables, right? Because all of the equations I wrote on the other side were with A, B, and C. Here we can see we have X, Y, and Z. Okay, so because we're trying to find the side length, we're using that first box of those formulas. Okay, we're looking for side Y, so I know that's going to be on my left-hand side. Remember from your formula, it is squared. Okay, the next one is you're adding those other two side lengths, so we're adding x squared plus z squared minus 2 times those two sides, all multiplied, remember, by the cos of the side we're trying to find. Okay, so that's the first step, right? We have to start by writing out our formula with the correct variables. Okay, the second step is to substitute what you know. Substitute. That is not spelled right. Come on. Substitute what you know. Okay, which just means fill in the information that you know, right? So let's do that. Again, I'm going to try my best to write this out as neat as possible given the space that I have. Okay, so we don't have y squared, right? That's what we're looking for. Am I gonna have enough room? I'll make it fit. Okay, so side length x, so 11 squared plus 8 squared minus 2 times 11 times 8 all times cos 36. Okay, when we are substituting, especially for multiplication, notice here how I wrote those in brackets. Okay, you're going to want to do that because you want to make sure that you remember that you're multiplying. Okay, at this point, obviously our next step is going to be to solve, but we need to make sure we're using BEDMAS. So step 3, solve using proper BEDMAS. Whoops. Okay, so remember that means brackets, exponents, division, multiplication, addition, subtraction. So we don't have any brackets here. Remember, those brackets that are there are just there because we're multiplying together, right? So technically no brackets. We can do our exponents right away, right? So, and you don't have to do this all in separate steps. I'm not going to do it in all in separate steps just because of space here. So we have y squared. Obviously, we can't simplify that, right? You type in your calculator, 11 to the power of 2 is 121. 8 to the power of 2 is 64. Okay. I can do that multiplication that's underlined as well in this step. So I have negative 2 times 11 times 8. You can type that in across your calculator. You're going to get negative 176. And that is all multiplied by that cos 36. Okay, so this here is still multiplication, so we can't do that addition yet. Okay, so our next line, y squared, you could add these two things together, but just for the sake of BEDMAS, we'll just leave them for now. So negative 176. On your calculator, again, you should know how to use it. You're either going to type cos and then 36 or 36 cos. You are going to get, let me just double check, cos 36, 0.8090. Okay, again, that is still multiplication here, so we need to finalize that. So we have y squared equals 121 plus 64. We're taking that cos 36 that we just evaluated and multiplying it by 176, which gives me negative 142.387. Okay, at this point, all we have left is adding and subtracting, so we can do that all kind of in one step. So 121 plus 64 minus 142 minus 387. Oh, that's a decimal. I was like, that doesn't make sense. Minus 142.387. There we go. So we get y squared equals 42.613. Okay, so now we know what y squared equals, but I don't really care about what y squared equals, right? What I do care about is what y equals. So just like we have in the past, to solve equations, we need to use opposite operations, right? So for this one, we have y squared. So the opposite of squaring something is to take the square root of something. Okay, that means these will cancel. What we do to one side, we have to do to the other. So I'm going to also take the square root of 42.613, and I get that y equals 6.5 inches. Okay, and that's, again, we're dealing in inches, so we want to include that information. Okay, so we've used the cosine law here to solve for our side length. So now we know what y is. Y is 6.5 inches. Perfect. All right. Let's try the next one here. So it says, find the measure of the marked angle to the nearest degree. So again, nearest degree, that means whole number. We can see here that we have all three side lengths, right? We have A, B, and C. The angle marked there is angle C, so that is the one that we are going to try to find. So again, the first thing that we're going to do is we are going to write out our equation. So our equation is going to look like this. C equals cos -1, and again, you're just copying this from the other side of your page. Because we're finding C, side length C is first. A is always first or second. All divided by -2AB. And again, we aren't putting C on the bottom, okay, because that's what we're trying to find. Once we have that equation, all we have to do is sub in the information that we know. So again, for sake of space, I'm going to keep going down, and then I'll shoot over to that right-hand side. So we don't know angle C, right? That's obviously what we're trying to find. So all we're subbing in here are those side lengths. So side C, again, maybe you want to label the sides on your thing so you make sure you're using substitution correctly. Okay, so they're across from the angle. So side C is 14 minus side A, which is 16 squared, minus side B, which is 17 squared. All divided by -2 times 16 times 17. A and B. Okay, and again, notice how with my substitution, I wrote those in brackets. Okay, so same thing as before. Now you are just simplifying. So just as a note, you want to simplify the numerator and the denominator before combining them. So simplify numerator and denominator before combining. Okay, which is before combining or like dividing is really what that is. Okay, so we want to simplify the top, simplify the bottom before we actually try to do any division there. Okay, so like I said, now I'm going to come across here. So we have C equals cos -1. Okay, again, we're following BEDMAS here. So on our calculators, we do 14 squared, 196, minus 16 squared, which is 256, minus B squared, which was 17 squared, which is 289. Okay, that is divided by -2 times 16 times 17. So divided by -544. Okay, so again, my denominator there is simplified, right? But I just want to simplify the top before I go any further in dividing those. So I have 196 minus 256 minus 289. So I have -349 divided by -544. Okay, those are fully simplified now, so I can carry out that division. So C equals, we still have that cos -1 out front of 0.6415. Okay, you can just keep that on your calculator. And remember to get to that inverse cos, you're just taking the shift or the second part of cos. So C equals 50 feet. Okay, on your calculator you should get 50.09 or something close to that. But again, remember the question asked us to round that to the nearest degree. Okay, so we have now used the cosine law here. Again, it's obviously, it looks different, but trust it's the exact same formula. It's just rearranged to help us isolate that angle. Okay, so one last example here. I'm going to draw out the triangle, but I'm going to have you actually solve this one on your own. So make sure you're doing that. So it says solve triangle ABC, given that A is 9 centimeters, B is 7 centimeters, and C is 8 centimeters. So obviously, when you're not given a sketch, it's always best to create one. Again, it doesn't have to look like anything in particular. Okay, just has to be a triangle. Once you have that drawing, you want to just label your sides. So I'm going to start by just labeling my angles. So A, B, C. Again, it doesn't matter how you label it as long as you label the side lengths across from the angle. So my side length A was 9 centimeters. My side length C was 8 centimeters. And my side length B is 7 centimeters. Okay, so right away we can see we have all three side lengths. Well, we could have saw that just from the question, but that means we are able to use our cosine law. Okay, so because it says that word solve again, remember that means that we need to solve this triangle completely, right? So that means we need to find all of these angle measurements, okay? Because we're working with angles, we're going to use that second equation arrangement, right? The modified one, so that we don't have to do any sort of rearranging, okay? So the first thing you're going to do is obviously just choose an angle to solve for. So it doesn't really matter which one you choose. Let's just say angle A. Okay, so you're going to use the cosine law to do that. And again, I want you to do this on your own time here before moving on to the homework. Okay, the second thing, we're going to have to find another angle, right? So let's say angle B. Okay, once you have a full ratio, right? If we solve for A using the cosine law, then we'll have a full ratio, right? Once we have a full ratio, why not just use the sine law? Okay, it's a bit easier, right? If you have a full ratio, use the sine law. Lastly, to find that last angle, remember the interior angles of a triangle will add to 180, right? So all we have to do is take 180 and subtract angles A and B. So to find that one, we're going to go 180 minus A minus B, and that will give you angle C. Okay? So I want you to take the time to do that on your own. Like I said, well, maybe I haven't said it yet. It's not always going to tell you which formula to use, right? Sometimes it will, but other times, like this one, where it just says solve, you are going to have to figure out what is the best way that I can solve this. You could have absolutely used cosine law to solve for all three angles, but that's a lot of work, right? We want to work smarter, not harder. So you want to pick the easiest method, basically. And that easiest method might not be the same for everyone. Okay, so this is my suggestion. Obviously, to find the first angle, you are going to have to use the cosine law because all you have is three sides. So that's the only option. Okay, but once you find that angle, you have a couple other options, right? You could use the sine law, or you could try the cosine law again. And lastly, to find that last angle, you could obviously use the cosine law or the sine law, but to make it even easier on yourself, just do 180 degrees minus the number you got for A minus the number you got for B, so that you can finish that off on an easy note there. Okay, so this is the end of the note on the cosine law.